Hello, today our topic is dilations. We talked about dilations in previous units when we were talking about transformations, but here it comes back now that we're talking about similarity. A dilation is the enlargement or reduction of a figure. So it makes it bigger or smaller. The scale factor indicates how much the figure will enlarge or reduce. The variable for the scale factor is the letter k. When k is greater than 1, the dilation is an enlargement. It makes the shape bigger. When k is less than 1, the dilation is a reduction. Makes the shape smaller. Let's look at an example. So number 1, we have triangle RST with vertices R, S, and T here. And our scale factor of k equals 2. So when we have our scale factor, we're looking at each coordinate of the point and multiplying it by that scale factor. So for R here, our x coordinate is -5. So to find our x coordinate in R prime, we do -5 times our scale factor of 2, which gets us -10. So that's what we write here for R prime's x coordinate. And then for our y coordinate is 1, we multiply that by our scale factor again to get 2. So for R prime, we have -10, 2. So -10 is all the way left 10 from the origin here, and then we go up 2 from there. So this is our point R prime. And then we repeat those steps for S and T. So starting with S, we have -3, we multiply that by 2, is -6. +4 times 2 is +8. So to get S prime, we go left 6, 1, 2, 3, 4, 5, 6, and then up 8. 1, 2, 3, 5, 6, 7, 8. This is our S prime. And then for T, we do those same steps. Our x coordinate's 2, so our T prime x coordinate is going to be 4, because 2 times 2 is 4. Our y coordinate's -1. -1 times 2 is -2. So our T prime is going to be 4 to the right, 1, 2, 3, 4, and 2 down from the origin. So this is our T prime here. So this is our dilated triangle. And because the dilation or the scale factor is 2, this triangle is 2 times bigger than the original triangle RST. Now let's look at problem 3. Here our scale factor is 1/2. 1/2 is less than 1, so this time our shape is going to get smaller. Our shape is going to be half as big as it originally was. We're still doing the same process of multiplying our scale factor by each of the points. So for J here, our J is -10 and 2. So we do our x coordinate times 1/2. 10 times 1/2. It's the same as -10 divided by 2, which is going to be -5. So for J prime, our x coordinate is -5. And then our y coordinate was originally 2. We do 2 times 1/2. That gets us 1. So we have -5, 1 for J prime. So that's left 5, 1, 2, 3, 4, 5, and up 1. Here is J prime. And then we have K prime. We find with the same ones, we do -2 times 1/2, gets us -1. 8 times 1/2 is 4. So we do right 1, up 4, 1, 2, 3, 4. Here is k prime. Let me erase those lines. And then L is 6, 2, so we do 6 times 1/2 to get us 3. 2 times 1/2 is 1. So now we're right 3, 1, 2, 3, and then up 1. L prime here. Let me erase these lines. And then M prime, our x-coordinate's -2, and we do -2 times 1/2 is -1. Our y-coordinate is originally -4. -4 times 1/2 is -2. So we go left 1, down 2 to get our point M prime here. This is our dilated rhombus. It got half as big as it originally was, so the scale factor made it smaller. Pause this video and try number 2 and number 4 on your own, and you can check with the answer key posted in modules. On the back side of this page, we have to start off with these 2 multiple choice questions. The first one says triangle ABC is taken to triangle A prime B prime C prime by a dilation. Which of these scale factors for a dilation would result in an image that was larger than the original figure? So if we're looking A, we have 3/5. This is less than 1, so this is a reduction. 13/17 is also less than 1. The numerator is smaller than the denominator, so this is a reduction. 1 is equal to 1, so this would not change the shape either way. 4/3, however, is greater than 1. The numerator is bigger than the denominator. So this one is the answer. This is the only scale factor of these 4 that would result in a larger figure. Try the next multiple choice problem on your own, and you can check the answer with the answer key. For these last 4 problems, we're asked to find the scale factor given the pre-image and the image. So let's look at 29 to start. To use this, we need to know that our scale factor k is going to be has the ratio the new shape over the original shape. So here our original shape is JLK. JLK here. And then our new shape is J prime, L prime, K prime. We can tell by the primes here. So the first thing I notice is that we have the sides for JL and for J prime, L prime. So we can count these to get our ratio for the scale factor. For JL, the original one, we have 1, 2, 3, 4, 5, 6, 7, 8. This side length is 8. And then for the new one, we have 1, 2, 3, 4. So we do the new over the original. We have 4/8. We can simplify this fraction with the A, B, C button in our calculator, and that reduces this fraction to 1/2. So this new shape is half the size of the original, and that makes sense because it's getting smaller. For number 11, this one's a little bit different because we don't have a side that we can count. We're still going to need the fact that k is equal to the new, something about the new shape over something about the original shape. I do see these points here. D is at 0, 1, 2, 3, 4, 5, 6. So it's at 0, 6. And D prime is at 0, 2. So I know the first number, the x-coordinate doesn't tell me anything because it's 0. Though that stays the same no matter what you multiply with it. But the y-coordinate, 6 from the original and 2 from the new, tells me what I need to know. So my new is 2 and my original one is 6. Because my prime points, 0, 2 is the prime, and that goes over 0, 6, which was the original. So 2 over 6 can be reduced with that ABC button. This is a scale factor of 1/3. Try these other two problems on your own, 30 and 12, and you can check your answers with the answer key in modules.